This recording is for a workflow for designing a pond in SS3. I want to first start by showing a diagram of a proposed pond and some of the controlling minimum clearance requirements that you typically have to design for. In this diagram, which comes from the drainage manual of the Florida DOT, you see that there are some clearance requirements in here from the right-of-way lines. Could be any sort of boundary line. It could be, basically your roadway slope. Could be lots of different things. And then typically they show the minimum 20 feet to this point here on a slope, which is a control elevation. And this control elevation is usually defined in the drainage hydraulics for a project, where you're trying to basically, this might be an overflow structure or something like that. It will have also a peak design stage, and then there's usually a freeboard requirement. And then there's also minimum maintenance berm to have on the pond, and then there'd be a cut fill. What I've done is created a template that is based off of this point right here, and then it will build basically this back slope, or this slope here, this 1-to-4 slope, and then also a berm slope, and then it will have a cut fill depending upon where the berm ends up based on a control elevation here. The other thing that you can have is a bottom pond elevation in order to determine the amount of volume, and that also we want to be able to modify in our design. So with that in mind, I want to go ahead and lay out a pond based on some right-of-way constraints or some boundaries. And I'm going to use the civil tools here. In this case, I want to use a single offset entire element. I'm going to set the offset to 20 feet, and then I'll select the line. I'm going to go ahead and construct green construction line. So I'm going to pick this right-of-way line here, and then set the offset, and I need to turn on my construction elements so you can see them. And I'll set the offset to 20 feet here, and go ahead and choose no for mirror. I'll do the same thing on this line over here. Choose no for mirroring. And now I'm going to pick a shoulder line out here, which is basically, this is a curb and gutter with a sidewalk, and then there'll be a buffer slope, and I want to start off with that buffer slope a minimum 20 feet also. So now I have these three offset lines, which are construction lines, and the next thing I'll do is go ahead and use the simple arc tool, and I'm going to put in a 35-foot radius between these lines. So now I'm going to select here and here, and then I'll go ahead and trim both, and I'll select here and here, trim both, and finally I'll select this last corner here and trim both. Okay, now that I have those out there, what I'm going to do next is actually create a complex element or a complex alignment from all of these. I'm going to go ahead and choose automatic, and I'm going to name this retention area. So this will be my retention area, my pond shape, what have you, to start from. And that's going to also be where my control elevation is. And then I'll have to adjust this boundary accordingly to fit it within the right-of-way constraints for a berm, and then also that slope. So the first element I'm going to pick is, I'm going to just pick it this way and let it go counterclockwise, and it will go around the actual alignments or the elements there, and it will create this complex shape. The nice thing about this complex shape is that now if I want to modify something, it's going to rebuild itself based on the geometry that it's ruled to. So in this case, I set this to a 20-foot offset. If I want to set it to -30, I can choose -30, and the radius is all update, and the pond reshapes itself. And I can do Control Z and send it back to that particular shape. Now the next thing I want to do is actually set the control elevation for this line. So again, what I'm doing is I'm setting this point, which would really actually, yes, it's this point right here, and then I'm going to set an elevation on this, a control elevation for my pond. So I'll go to the vertical geometry tools. I'll select the profile for this element, open it up in a view, display it in this view, and I can see that basically where my existing terrain exists for that. And let's say that I have a control elevation of 32 feet. So what I would do is I would use this profile by constant elevation tool, and sometimes you have to select it twice, and then in the dialog I can either key it in here or I can click the element and then reset, and it will follow along with me on the cursor, and then I can set 32 feet as the control elevation and data point, and now you see a new profile. Basically a flat profile line has been set for that control elevation profile. So then next what I would do is go ahead and set the active profile here. That's what it was. And so now this element should have an active profile, and it says active profile exists, and it still should have showed up in this view here, which I'm not sure why. But the next step here in this workflow would be to place that basically that pond shape around that element. And before I do that, I want to show you what it looks like in the template. So I've created a linear template here called Pond Design. And so what this does, this is the control elevation. It uses this 4:1 slope. It goes down to a break point, and that break point can be, you can set that in another control elevation down there, which is 3 feet below the control elevation. Or you can set it to a distance, however you like. In this case, it's also set to, well, whatever that distance would be times basically about 15 feet. And then actually it's more like 13.2 feet. And then you can do the same thing here. You set the pond bottom another so many feet below this control elevation. So if you wanted to modify that, you could go ahead and set that as a different elevation. And then again, it wanted to have 2 foot of clearance above that point. So there you see the 2 feet above the control. This would be for the peak, and then a foot above that would be the freeboard. And then what I've done is just put in a 15-foot berm that's at 0% slope, and then I defined a cut situation and a fill situation. And that would be the linear template that I would place along that line. So we'll go ahead and do that and select the apply linear template. Locate the element to apply the template. So I'm going to select this line and select the template, and now it's going to find the begin station and the end station, which happens to go around itself, and so it begins at one point, goes around the circle or the pond shape, and then it ends at the same point. And then I will go ahead and choose this reflect option to be inside the pond, and then the corner sweep angle, and I get basically I get the pond designed out here. And you can also see that my TOA slope lines now for my pond are reaching well outside of the boundary limits. So then it would just be a matter of going into my pond design here and modifying these widths. And it looks like I probably needed to have more like 35 feet to move that inside of it. And the same thing with this side. I can set this value here to, well, that's the radius. I want to set the offset value here, and because of the way the line was, the actual middle of it is right here, the original design intent. So I'm going to set this to 35 feet. And as you can see, the pond is redesigning itself. And then the same thing for this shape right here. I'll set this to 35 feet. And then also you'll notice that as this control elevation moves up and down, the pond will redesign itself as well. So I'll go ahead and choose this. Instead of being 32, I'm going to set my control elevation a little lower. And now you see that the pond has redesigned itself, and it's basically fitting within the limits of the right-of-way and the roadway slopes. There may be a little interference here in these roadway slopes, and that may be a matter of going in and adjusting your template so that it ties into the pond edge. But that's essentially what you could do. It would also work if you were to redesign some of these radiuses. If you wanted to make this a little tighter, change it to 30. You can go to a 30-foot minimum. And if I do a Control Z here, you'll see that that radius has been modified. Okay, now how do you get the volume out of this? Well, in order to get the volumes, you need to create terrains. But one other thing before I do that is right now the bottom of this pond is going to be at a specific elevation based on the template. But if you wanted to set this pond at a fixed right now it's 5.3 feet below this, whatever the control elevation is, but if you wanted to set it to a specific elevation, you could. So let's say we wanted to put the pond down at elevation 25. Actually, let's say instead of 25, we're going to make it 8 feet deep, so we're going to set it to 22. With linear templates, you can actually apply point controls. And if I go back and show you this template, in the linear template for the pond, there actually is this point here called pond bottom. So we could apply a point control to this such that if we were to modify the vertical, here I'm going to show you by testing a vertical point control. If we move this pond bottom up and down, it's going to basically extend that 2-to-1 shape there. And we could also set an elevation on this point as well if we wanted to, which is where the break was. Let's say we wanted this 4 feet below, and then this one here to be another 4 feet below. So what we could do is go ahead and then I'll show you if we test this vertical point control, you'll notice that this moves too. And then this pond bottom, right now it's set to vertical below this one. So what we're going to do is override both of the vertical constraints in the template. And so the one is a pond break and the other one is the pond bottom. So I would just go over to the Create Point Controls dialog, and I would locate the corridor and set the begin and end station. And then in this case, I'm going to set this as the break. This is just the description. And then the point is going to be the slope break point, the pond slope break. And then I'm going to use a vertical, elevation, and grade. The elevation I want to set is 30 feet minus 4, which would be 26. Enter that elevation. And then the grade would be 0 because I want to stay the same grade, priority 1. It will adjust the pond that way. And then I can go ahead and do the same thing with the pond bottom. And what you see here is that this slope actually got a little closer to the bottom. So now we're going to put the bottom control elevation, and we're going to call this the bottom. If you want to put under by elevation, you can. And now I'm going to use the pond bottom point and the vertical elevation and grade, and I said I would put it 4 feet below the break, so I'm going to set it to 22. And as soon as I click this button, you'll see this slope will lengthen. Set the grade and the priority. And now I've got basically that. And if you want to see it, we'll go ahead and cut a cross section in it in a second here. Actually, I can go ahead and do it now. So let's say that now I want to see what that pond looks like, and I don't physically have a bottom on it yet to actually measure, but I can see what the template shapes are going to do. So in order to cut a section, I'm just going to click on this roadway corridor here, and I'm going to go to a cross-section view, and I'll open it up in view 4 here. And here now you can see there's the shape going for both edges of the pond as it cuts through this line right here. And if I zoom in close enough, you'll see that this is actually at 22. This point is at 26. This point's at 30. And then this point here is going to be 2 feet above it, just because that's my peak stage. And then my freeboard will be at 33, and I'll have all my controlling elevations for the pond designed that way. And you notice that now I'm moving inside, and I could adjust those parameters as I need to in order to get that pond to fit in that shape. Now, in order to create the volumes for this, we're going to create a terrain. And then we're going to do that actually over here from this 3D view. So let me just rotate around here. And in order to create a terrain, what I want to do is I want to select the break line elements that make up this pond. I don't necessarily need the shapes. So in order to turn the shapes off, and then I can just turn off the PX, ditch bottom PX and ditch PX, and now I have only the shapes that represent, I'm sorry, there's also one more, which is probably slopes, and that is slopes PX. So if I turn off the wrong one, slopes PX. So what that does is it only displays in here these lines. And if you want to go to a top view to see what it looks like, so it's easier to select, you can see that I've got each of these lines. And I do have a little cut and a fill line out here. So what I'll do next is just create a selection set of all these lines. And I didn't get that cut line, so let me get that as well. And once I have all these in a selection set, then I go to the terrain, add elements to the terrain. There's down here, it tells me there's 8 in the selection set. I can also see it, well, actually over here it says 9. These are going to be, you can bring them in as break lines, graphic break lines. And I'm going to go ahead and set this to edge method none. And then I'm going to go ahead and set this to a DTM proposed, and I'll call this a DTM pond. Okay, and then I'll go ahead and data point to select, to add the selected elements, use graphic break lines, edge method none, and I will actually get over in this view. If I turn on the construction elements, you'll see now I have a pond in here. And if I change the view here, you see I've also got this pond now displayed in the cross section as I come across here. And I still have control over this, so that if I change something in my design, whether I change it the horizontal offsets or if I change this vertical elevation, it actually updates the terrain as well. One of the other things that I want to do is densify the elements along this terrain, and what it's doing currently is it's using a stroking interval to drop the templates, and the stroking interval is defined on the actual element itself. So if I click on this element and go to the properties, you'll see that there is a linear stroking of 50 feet. And what I want to do is change this to something a lot smaller, let's say 5 feet. And when I do that, notice that my terrain gets a lot tighter, a lot smoother. Now the only thing left that we need to do is actually figure out what the volume of this pond is. So there is a tool over here in the analysis and reporting, which is a analyze volumes tool. And there's several options to use in this, but the one that we want to focus on in here is, if you see here, there's terrain to terrain volume or terrain to plane. So what I want to do is I want to see what the volume is at that peak, I'm sorry, at the control elevation of 30, and then I can also do it to the control elevation of 32 or the peak elevation of 32, and I can actually plot it out here in the design file. So what I'm going to do is go ahead and choose terrain model to plane, and then set this plane volume to 30. I'll go ahead and select the terrain now, which is this pond, and then it chooses 30, cut factor of 1 and a fill factor of 1, reset for a boundary. I don't need that. Save the results, yes. And then I'm going to place, it's using the active, whatever the active level is, so I could go to a text level here, just put text notes, and place this right here. And then I'll go ahead and choose the command again. Terrain to plane, locate the terrain, change the control elevation to 32, and choose that, cut factor, fill factor, reset for a boundary, save the results, and now I'm going to plot this one right here. And then we'll go ahead and open the view up and compare it. So now these are just text elements at this point. They're not related back to the pond or the terrain in any manner. So if we were to make changes to any of our controls here that changes the pond design or the actual terrain, you would have to basically redisplay or recalculate and analyze those volumes. So that concludes what I wanted to record for a pond design in SS3.